Welcome to SIM Consulting's presentation on the McCarthy Bridge Rehabilitation and Widening project. We are civil engineering students and our names are Kate Christ, Felize Ilao, Kathleen Morton, and Robert Moser.
McCarthy Bridge is a twinned concrete bridge with 2 piers and 3 spans per structure. Each structure supports 2 lanes of traffic. The bridge is located in western Regina and passes over Wascana Creek. Surrounding the site is Rick Hansen Optimus Playground and A.E. Wilson Park. Shown below is a map of Regina's multi-use pathway system. The sidewalk of McCarthy Bridge connects the paved pathways within the surrounding area. There are 2 main objectives with this project. The first is rehabilitating the existing bridge by addressing the chloride ingress present in the bridge deck. The original deck was 75 millimeters of concrete with a 90 millimeter polymer modified asphalt or PMA layer. The second objective is to widen the existing 1.5 meter sidewalk to 3 meters. This extension will facilitate the installation of a dedicated bike lane, while increasing pedestrian accessibility in the area. The McCarthy Bridge project will assist the City of Regina's Transportation Master Plan to improve transportation methods in the city. Increasing foot and bike traffic in the Wascana Creek area will promote active transportation for healthier communities.
A load rating was done using live load capacity factors, where a value greater than 1 indicates sufficient capacity in a structural component. The pier columns and abutments were well within the acceptable range and are therefore not shown here. The sidewalks required replacement during the widening process and were therefore not assessed. The exterior girder was found to have insufficient shear capacity under existing conditions and was also found to have insufficient flexure capacity after widening. The cantilevered portions of the pier cap had insufficient shear and flexure capacity on both the median and sidewalk sides. SIM Consulting redesigned these elements to address these issues.
To address the chloride ingress on the bridge deck, SIM Consulting recommends removing the existing PMA layer and 25 millimeters of the concrete layer. Removing these layers removes the areas affected by chloride ingress. The existing steel reinforcement and 50 millimeters of the concrete layer is left. In its place, 70 millimeters of new concrete overlay is recommended. SIM Consulting considered using waterproofing bituminous membrane, corrosion inhibitors, and a combination of both to mitigate chloride ingress in the future. A waterproofing bituminous membrane is the most cost-effective solution and is recommended to be placed on top of the new concrete overlay. Finally, 2 30 millimeter thick PMA layers would be placed on top.
SIM Consulting considered increasing the pier cap depth by adding concrete, attaching steel plates, and a combination of both alternatives to reinforce the pier cap. The combined alternative was selected as the most feasible and cost-effective design. SIM Consulting recommends the depth of the sidewalk side pier cap be increased and half-inch weathering steel should be added to support all pier caps. The steel will be concentrated in the tension zones of the structure to utilize the strengths of the materials and ease installation. To ensure composite action, additional steel encasing the tip of the cantilever will be added, and 3/4 inch concrete wedge anchors applied over the full length. SIM Consulting has also designed a new exterior pre-stressed concrete girder to resist the higher loads.
The sidewalk needs to be widened in order to have a total of 3 meters of walking width. The proposed construction plan is a 3-step process. First, a point support will be added. The point support provides an easy and cost-effective method to prevent overturning upon loading. Following the point support, the sidewalk is cast onto the exterior girder. The new sidewalk is 3 meters as per our client's request. A tapered sidewalk is used to minimize the concrete required while still providing sufficient capacity. After the sidewalk is in place, a barrier is installed. The barrier increases safety for traffic and pedestrians.
Adding space for bike traffic on this bridge will improve Regina's multi-use pathway network and facilitate active transportation in the community. Rehabilitating this structure is only 35% of the replacement cost and will also minimize the consumption of new steel and concrete, both of which create pollutants in their manufacturing process.
This project is estimated to cost approximately $2 million and take approximately 10 months to construct. This design will provide a wider sidewalk for a multi-use pathway and will mitigate future damage due to water and chloride ingress.
We would like to thank Dr. Feldman and Jim Zacharuk for their technical guidance on this project. We would also like to thank Professor Schmidt for coordinating the capstone course and Dr. Sacchi for coordinating this event. Thank you.